This lecture is going to be our first introduction into the momentum principle, which is a very powerful relationship. And it's a restatement of something that we use quite often to talk about how things react when there's some sort of force or something acting on them. And that's generally called the cause and effect. This principle, of course, bleeds over into lots of different kinds of things, but in physics it has a real meaning in the sense that physical systems undergo a cause and effect kind of relationship that's usually talking about how things move in time. Okay, this principle of the momentum principle, this one thing, has been tested on many scales, and basically all scales of the known universe obey this rule. And so, to put it in words, I would say that the change in momentum of a system this is the effect part, is equal to the net force, we'll call that F net, and we'll define that in a moment, acting on that system. So, this is the cause. So the cause and effect relationship is that you change your momentum when you are acted on by a force. Okay. What does this force sub net mean? This is a new concept, so we're going to spend some time. We are familiar in our daily lives with forces. Things push, things pull. But what does it mean? So delta P, we know, this is change in either magnitude or direction of momentum. How about F net? F sub net. This is a vector quantity, and it's defined as the total force acting on the system. It's all of the forces added up vectorially. It's a vector sum of forces. Okay, so those are our two things that we're going to now put into an equation, put into a form that we're going to use over and over again to understand how systems react to forces. Delta P is equal to F net delta T. This is the momentum principle. Delta T we know, but it's got an important meaning here. Delta T, in a sense, is associated with the net force. It's the time, the interval, over which the force is applied. That's important. This time is related to the amount of time that the force acts on my system. So that's an important detail. All right, so let's break down forces. What are forces? How do we define forces? Okay, so a force it's a vector quantity. Will have components. It will be ascribed to a position in space, perhaps, or to an object. Forces have units. Shockingly, they are called newtons. It's a shorthand. The units are actually given by the following: mass, that's a unit, times length, divided by time, times time squared. Okay, so in order to understand how these units work, we can look, for example, at a couple things that might have mass, length, and time squared. So a familiar use of force would be our old friend from previous physics understanding, and that's mass times acceleration. This has units of mass. This has units of length per time squared, which is exactly what we get. But we're not going to use this equation very much in this course. We're going to really think about forces as being associated with changes in momentum. Okay. So like I said before, we have two considerations. One is system. That's our thing of interest, system. And then we have the surroundings. That's everything that could exert a force on my system. And then we will always, for this chapter at least, for a little while later, we will consider different kinds of systems and different ways of breaking up systems into pieces. But for right now, our system will be the object of interest. It's to be the thing we start to do calculations about. F net we can define as all of the forces, all of the vector forces, F1 plus F2, I don't know what these are yet, F3, any set of forces that might be acting on my system. So net force acting on the system due to surroundings. So I could do this in a vector way. So let's see what that would look like. Let's have a bunch of forces that can act on something. And let's say at some point on some object, I'll draw a little object here, there may be a force in this direction, I'll call that one F1. There may be a force in this direction, I'll call that F2. There may be a force, thank goodness I only have 3 colors, in this direction, I'll call that F3. Gotta put a vector on F2. So there are my 3 forces that might be acting on my object, on my system. What's the net force? Well, it's the vector sum. I take this vector, I add it to this vector, I get a vector that's slightly pointing downward. And then I have this vector that's the result. F net is this way. There we go, vector sum. I take this vector, add it to this vector, and this vector, I get one that's slightly pointing downward and slightly longer. Because these have components, that has a component. The components that line up sort of cancel out. I have one that's left over. Okay, so sum of all the forces. Any other extra forces, I can add them up. So what we said before was that delta t is the time interval over which the force is applied to my system. Time that F net is applied to the system.